Okay, so this is the example for number 1 for this weekend's homework. And what we're just going to be doing is looking at different ways to express exponents and also different ways to express roots, because there's a connection between the symbol for the exponent and the symbols for the roots. And we're just going to be looking at those, and then also just talking about how to evaluate them, how to convert them to a final numerical value. So I guess the first thing we just want to talk about is the fact that this exponent is a fraction instead of a whole number. So anytime we see this, let's just identify what each part of the fraction means. When we rewrite this, the numerator, the top of the fraction, is going to be the exponent. And the denominator, or the bottom of the fraction, is going to be the root. So let's go ahead and just rewrite 25 in the next column. And then instead of using a fraction as an exponent, we're going to split it into a root and an exponent. The root is 2, so it's square root, and you do not have to write it 2. Remember, for square root expressions, the 2 can be silent. In fact, the 2 is usually silent, but that's that 2. And then the exponent is 3, so we can say that this is square root to the 3. Or there's another way to write this. The order that you do these doesn't really matter. So you could say it's 25 to the 3, and then a square root for the 2 value. And like I said, you do not have to write the 2. In fact, usually you do not, so let's take off that 2. The 2 is silent. So that's just the idea that if you have a fraction exponent, the bottom of the fraction tells you the root amount, and the top of the fraction tells you the exponent amount. And now we can actually just go ahead and evaluate this, because look, we know what the square root of 25 is. It's 5. And then now that we've done that, we've done square root, we can cube it. So 5 times 5 is, well, 5 times 5 is 25, times 5 more is 125. We could also have evaluated this expression. This came from doing this one. We did the square root step first. Square root of 25 is 5. And then we cubed it and worked it up to 125. We could do this one, although by hand, I don't think I know 25 cubed by hand. 25 times 25 times 25. I'm just going to have to type it into my calculator and see what that is. Apparently it's 15,625. I did not know that. And now we're not done. We still have to square root it. I think offhand we do not know what the square root of 15,625 is. It should be 125. Let's just type it in here and make sure. Indeed it is. So we got the same answer either way. But if we looked at these two choices, this one's a little bit easier to work out mentally, because we know square root 25 is 5, and then we know how to do 5 times 5 times 5 and get 125. So this version was pretty friendly to work through. This is the exact same amount, but you have to know what 25 times 25 times 25 is, and that's a little outside of the math that we usually do in our heads. And then you have to know what the square root of this number is, and that is definitely outside the math we do in our heads. All right, so I'm going to erase actually a little bit of this so we have room for the next problem. We're going to erase that version of the solution. All right. We got 216 to the 4/3. Once again, we just want to identify that the top is the exponent, and the denominator is the root. So what we're going to do is just rewrite this as a combination of exponent and root. In this case, the exponent is going to be a 4, and the root amount is going to be a 3. Or we can do the root first, and then add on the exponent. Either way is totally fine. The order doesn't matter. At least in this case. If I look at these, I definitely don't know what 216 to the 4th is. I actually recognize cubed root of 216, because 216 is what you get when you multiply 6, 6, and 6. So it's a cube that I know. So let's use this version. The cube root of 216 is 6. And then we still have to raise it to the 4th power. So it's 6 times 6 times 6 times 6. Oh, times 6. Which I actually don't know off the top of my head. So it's perfectly okay to use the calculator to crunch some of the numbers as long as we understand what these symbols mean. And it's 1,296. And then let's do one more example. In this case, we're not given just an exponent that uses fractions. Instead, we're given an expression that's a combination of a root and an exponent. So we're going to fill in that left column. Remember, the top of our fraction is supposed to be the exponent value. So this is cubed. So we're going to have 32. We're going to have 32 cubed as the top of the exponent, and then the root value is the denominator, so this is 32 to the 3/5. We also want to go ahead and work out the value for this. 32 is actually 2 times 2 times 2 times 2 times 2. So that's 5 2s, so the 5th root of 32 is 2. And we still need to cube it. 2 times 2 times 2 is 8. Whether or not you know that the cube root of 216 is 6, or that the 5th root of 32 is 2 is not important. The most important thing about this question is understanding that a fraction, an exponent that's a fraction, can be split into a root for the denominator and an exponent for the numerator. That's the main thing I want us to take away from this question. How you crunch the numbers and how much of a calculator you use really doesn't matter. What really matters is the denominator is the root. The numerator is the exponent. That's the key thing I want us to learn in these questions. All right, hopefully that helps with number 1. For number 2, which is using quadratics to model projectiles, please check out the next video.